Hello my dear viewers, welcome to my channel Math Mantra. In today's video, let us discuss Phi correlation, how to find Phi correlation coefficient, its formula and a simple illustration to find the correlation coefficient. If you are new to my channel, please do like, share and subscribe my channel for more videos. So let's begin the class. First of all, let us see what is Phi correlation coefficient. It is Pearson's correlation coefficient when the variables between which we are finding out the relationship are both dichotomous. Dichotomous variables, I have already done a previous video. What is the definition of dichotomous variable and how it is different from the other variables. So since the variables whose relationship we are finding out, since they are both dichotomous, it takes exactly two values. Here variables we can code as 0 or 1, either 0 or 1. Now Phi coefficient is used to establish relationship between two variables which are discrete. So both the dichotomous variables must be discrete variables when we find the Phi correlation coefficient. The Phi correlation is also called mean square contingency coefficient. For example, when we find the relationship between gender and left or right-handedness, this correlationship or the relationship between gender and left or right-handedness, we can find out by using Phi correlation coefficient. Another example is gender and scores on achievement test. Phi coefficient can be positive or negative. As we know, the correlation coefficient, when we find out, you can get values which range between -1 and +1. So here also Phi coefficient can be positive or negative. So it is normally represented in terms of a 2 by 2 table. Since the variables which are involved here exactly takes two values, or otherwise we can say the data is a binary data whose relationship we are establishing or we are finding out. So let us see how we find out the Phi correlation for a given binary data. So here the table gives you a simple illustration for finding out Phi correlation coefficient. So here we have taken two variables x and y. Here y variables take two values as already mentioned in the previous slide, 1 and 0. Similarly, the variable x takes value 0 and 1. So these are the codes assigned for the variables. So for example, to make this concept more clear, we can consider gender, which takes exactly two values, male, female, and the results for exam, pass or fail. So again, two values exactly. So x represent 1 if it is a pass, similarly 0 for a failure. So here we can see the entries N11, N10, N01, N00. So these are the frequencies which represent whether the female or a male member who is getting passed or who is failing in the examination. That means if we take N11, the entries in the first column representing N11 here, it will be the number or the frequency or how many male candidates passed the examination. Similarly for the rest of the entries. So hope this concept is clear to you. Now let us see how to find out Phi correlation using the formula. Now the formula for Phi coefficient, it's given by phi is equal to AD minus BC divided by root of A plus B into C plus D into A plus C into B plus D. Now to find out the Phi correlation coefficient, let us take an example. So here, to establish the relationship between a standardized test result and an achievement test, let's see how we can find out the Phi correlation coefficient between these two test results. So here we have to take a criterion, here I have taken the mean of the scores and the scores below the mean score as well as the scores above the mean scores. So minus mean represent how many scores are there which are below the mean score, and plus mean represent the total number of scores which are above the mean scores. So from the table you can see the values which are entered here, which are the frequencies representing below mean score and the above mean score: 32, 28, 18, 22. So which represent A, B, C and D. Now we can use the above formula and find out the Phi correlation coefficient between these two test results. Now when we consider Phi coefficient, it can be positive or negative. If AD is greater than BC, the value of the correlation coefficient will be positive. Also, if AD is less than BC, the value of the correlation coefficient will be negative. So, depending on the values of AD and BC, we can get positive correlation coefficient or negative correlation coefficient. Now, let us substitute the values of A, B, C and D in the formula. So here we have A is 32, B is 28, C is 18 and D is 22. So substituting AD minus BC, we get 32 into 22 minus 28 into 18. So here we can see the product AD is greater than product BC. So definitely the value of the Phi coefficient that you are getting will be a positive value. So the correlation will be positive here. Now denominator, square root of A plus B into C plus D into A plus C into B plus D. So we have the values substituting. A plus B is 60, C plus D is 40, A plus C is 50 and B plus D is 50. Now simplifying the above values, we can find the value of the correlation coefficient as 0.08, which is a positive correlation. But since the value is 0.08, there is a weak correlation between the standardized test result and the achievement test score. So this is the method of finding Phi correlation between the two dichotomous variables. Hope the method of finding Phi correlation coefficient is clear to all the viewers. That's all for today's video. Hope today's video was helpful for you to understand how to find out Phi correlation coefficient between two dichotomous variables. So if you feel my videos are helping you in understanding the basic concepts in statistics, please do like, share and subscribe my channel. And I wish all my viewers and my subscribers a wonderful 2022. See you soon with yet another topic in statistics. Until then, stay safe, take care. Thank you.